Hi Sumant, hi Syed.
Yes, sir. Hi. Assalamu alaikum.
Walaikum assalam. Okay, this is within. Hello Sudipji, how are you?
Hello, good evening.
Good evening.
So we meet after a short gap.
Yeah, exactly. There were some issues. Okay, let's start. Everybody joined? 7. Okay, okay. So see, there are different types of electrical drawings that we use in our industry, and the drawings are your schematic wiring diagram or schematic drawing, your wiring diagram that we say P2P or wiring diagram, ladder diagram, single line diagram, etc. Okay, so you can say there are four basic diagrams in electrical: schematic, wiring, ladder, and single line diagram. So now what are the differences? In your schematic drawing, there might be your symbolic, it can be symbolic or it can be your pictorial that we already used in our during our school or college days, and just there will be some pictures and we are connecting, and this is called your simple systematic or schematic drawing, is not it? So this type of, this is your pictorial where actual pictures we are using. This is something symbolic where we are representing this bulb with this circle and cross, and this switch as this one, two dots and a bar. So this is your schematic drawing. Now what is your wiring diagram? Wiring diagram is also called your P2P, means point to point diagram, and it gives you the full information, complete information mainly. See, in case of your schematic diagram, you can get some idea or a brief idea about all the elements and what the circuit is for. You can get it. But in your P2P diagram, you will get all the information. Means regarding all the wires, cables, where it is being connected, and from point to point. That is why we call it point to point diagram. Wiring diagrams gives the information about how the wires or components are actually connected, as well as their physical locations. Means, what do we understand by physical location? Means which switch is coming before and which switch is coming after, and which wire is going to connect this. And we also call that, okay, documentation of this drawing. Documentation means we assign some numbers. You all know that there are some variable numbers. So how we assign those variable numbers? This is also called your documentation of the P2P drawing. Likewise, we can give number 1 for this line, and number 2 for this neutral, and then all the connected wires we will be giving some numbers. Another question is whether we give numbers to wires or what, because there will be so many wires, isn't it? And we can see that there are same numbers might be in 3 or 4 wires or somewhere like this. So exactly, we do not give number to wires. We give number to the node. Means the node where 2 or 3 branches are connected, we give number to that particular node, and all the wires coming in or out from that particular node, we give the same number. Is that it? So this is called your wiring diagram, or your basically it is your P2P, point to point diagram, technically. Next one is your ladder diagram. Now, in case of your ladder diagram, see, this is not ladder logic. Okay, don't mix up with the two. That ladder logic that we use in case of our PLC, and the ladder diagram that we see in case of our electrical, both are two different drawings. Exactly from this ladder diagram, electrical ladder diagram, the concept of PLC or the concept of ladder logic came. Okay, so what the ladder diagram represents the logical flow of the electrical circuit. It shows us each and everything, the process, but it do not give the location, the position, or the wiring sequence. Okay, so ladder diagram is basically represents the logical flow. Means if this is on, this is off. So you can see from this. So there are same as in case of our ladder logic. There will be your rails. Two rails will be there. One will be line, one will be neutral, and then in between these two vertical line, we draw all the components, electrical components sequentially. Now suppose you are connecting a motor here over here, and all the switches, all the inputs in the left hand side, and the output is connected to the neutral, and this is what we call the ladder diagram for electrical. Now difference between your ladder diagram and P2P diagram: ladder is not your physical representation but logical representation, okay, of a wired system, but point to point or P2P wire diagram shows the actual wire. So I hope you understood both the difference between this wiring diagram and your ladder diagram. Okay, so mainly what you see in your industry when you are opening some electrical drawing, so it is basically your wiring diagrams or it is your P2P diagram. And another one is your single line diagram. Now, what is the difference between your wiring diagram and your single line diagram? So, single line diagram is the representation, single line representation of your balanced three-phase system. So, when I am representing a generator of 25 megawatt here, then a transformer 11 kV by 33 kV, and a bus bar of say this will be a 33 kV or so. So it is, I am representing it with a single line, is that it? But basically what it is a three-phase system. So we are representing only one phase with this diagram. That is why we call it single line diagram. And since it is a balanced system, so all the rest two phase will be of with same nature. So single line diagram or SLD represents the three-phase electrical system in simplified notation. So phases are represented by a single line. That is why we call it single line diagram. Okay, so now I hope you have got the idea regarding these wiring diagrams. Is that it? What I was talking in my last lectures, that draw P2P diagram means I was expecting this kind of drawing, simple and which will give you the detailed information what you are connecting with what. Okay, and another thing I ask you people that, okay, do the actual wiring diagram, so that actual connection, how you are making the actual connection. Okay, not going in detail of this much right now. I'm skipping this part. So if you just let me show you concept of phase neutral and earthing. I hope you people know, but still some of you might not be having the some knowledge, so I am telling you people. Suppose this is my generator, is that it? So if it is my generator, so since it is a three-phase generator, then it will be having your 6 terminals, is that it? 3 terminals will be in one side and 3 terminals at the other side. So the 3 terminals, what we do, the 3 terminals will be shorted and it will be ground or earth through NGR. Okay, through NGR we ground it, and then other 3 terminals are connected with your transformer, power transformer. So you can connect a 11 by 33 or 11 by 66, 11 by 132 kV, whatever it is. So by step upping, what we do, we first generate 11 kV, then 132 kV, and then 132 it is transmitted to the substations, and then once again we use some step down transformer, and 132 kV to 33 kV, then 33 kV to 415 volt to the distribution transformer, is that it? And the distribution transformer is your 415 volt and 220 volt transformer. So if we see here, the star connection is at the at one side of the generating station, and then all rest are your delta to delta connection in between the transformer, and at the user end, when you are connecting your distribution transformer, then it is once again your delta to star connection. So this is something you need to know, that okay, how electrical connections exactly we make. Now from this distribution transformer, we give supply to our home or to the industry. So if we consider this is my distribution transformer, and there are three phases like RYB, and we can, what we do once again at the user end, since it was your delta was coming, and now what you are doing, you are making it once again to the star connection. So you are making a ground or earth here with this transformer, and then taking this arc as a neutral connection and one phase as your single phase, isn't it? So you can give connection to single phase that we are having in our house lights. If you are using single phase line, then one phase will be coming to your home and another phase will be going to some other's home. So suppose our phase is coming to this particular house number 1, and house number 2 is having your Y phase. House number 3 or 7 may have some different blue phase. So we can connect it like this. So now you can see here, it is your line is coming to your main MCBs and one neutral is coming. And you are we are giving a local ground that we call your earthing, is that? So we connect it like this. So this is all about your neutral and earth. Earthing is the local ground and neutral is the common ground. Okay. So this is exactly, this is not something not in the context of this particular course. But since you people are finding some difficulties, that is why I have to go through this as well. So if you see the contactor, then just for a going in a rapid manner though, but I was expecting that people know these things because these are the basic things, and we were talking some, we were trying to talk some with some advanced level things, is that it? But since you people are facing problems, so just a brief idea regarding this. So this is your contactor, and we know that in a contactor there will be some coil which A1 and A2 terminals will be there. Then there will be some fixed contact and moving contact. We connect it with the fixed contacts, isn't it? So this might be NO or NC, and so then this is something like how a contactor works. So one is, suppose the switch is now open. If the switch is open, current is not coming to this coil. This coil is connected to one line and one neutral. And if once I just switch on this, current flows through this particular coil and a magnetic field is generated, and this is what it is doing. It is attracting the armature, okay, and the switching is happening. Likewise, this is your NC point and this is your NO point. So see how the circuit is working. So this is how exactly our contactor works. Okay. So we can connect multiple circuits, we can control multiple power circuits with the help of this single contactor. So this is, anyways, okay. So Pintu, now got the idea regarding your this particular thing, P2P drawing, is that it? So what I was expecting from you, I am just giving you one idea regarding this motor control through your PLC or DCS. Suppose we were considering your direct online circuit, is that it? So in case of your direct online circuits, I told you people that okay, don't go for the power circuit, just draw your control circuit. So what you could or what you were supposed to do, there would be a neutral line and there is a sorry, one line and one neutral. Okay, and you we give number one to the line and number two to your neutral. See, okay, it is a convention. In general, you can uh, do it in other way too, but the numbering, that documentation I told you people, that if there is a line and neutral, then you give number one to the line and two to the neutral, and then you connect other lines. Likewise, one fuse will be there, and then from fuse you are going to connect one your overload relay. Then what you are connecting, you are connecting your local stop push button, then your start push button, then your coil, and simply you are giving a holding. So this particular drawing is called your P2P drawing or your wiring diagram. Okay, so this gives me the full information, and even I can add the node numbers. Likewise, if this is one, so this will be one. So one ferrule will be connected here at this terminal as one. One ferrule will be connected at this terminal as one. Again, then if it is one, and we have already given number two to the neutral, so you have to give, you can use three here, three to this node. So we are giving the node number as this node as 3. This particular node is 3. So if there are multiple cables going out from this particular node, you will be using in both sides 3, so that you can easily identify the cables. So this will be your 4, 4, this will be your 5. So if it is 5, this node is 5. So 1 5 will be there. Here also it is 5. Here also you will write it is 5. Okay, then this will be 6, and this will be also 6, and this will be also 6. See, this is a single node, same node. Then this is your 2. So this is what we call the numbering of the nodes. Okay. Now, if this is my wiring diagram of the circuit, then we come to the actual wiring. Actual wiring means what I expected from you, that you draw this particular panel. Okay, this is my panel. Then this is my contactor, say, and just now I have shown you that okay, there will be 2 terminals for the coil. One is called A1, another one is your A2, and there will be one NO contact 13, 14, and other NO contacts, is not it? So one overload relay will be there, one fuse will be there, one stop push button, one start push button, and 3 indicators. So this is what exactly the basic things that we can see in our panel. Now, one line, one neutral, and now I start connecting each and every point. So this is the panel. Okay, this is the panel in front of me. Now I start connecting each and every points. Like first, from where I should start? I should start from point number 1. So I should connect your line to the fuse. Then from fuse, I can see from fuse it is going to my overload relay. So I am connecting this from fuse to overload relay. Then overload relay, it is NC point, and from this point it is connected to your local stop push button. So from this point it is connected to your local stop push button. From stop push button to your local start. Okay. Then from local start to the coil. Okay, so I have connected here to my A1 point. Now from A2 point, this is A1 point, this is my A2 terminal. So from A2 terminal to the neutral line. So it is connected. Okay, so this is a closed circuit right now. Current will be coming from this point and going through this, since it is all connected, it is all connected, it is all connected, since it is stop push button and it is NC. So current will be up to this point, is that it? Up to this point. So now if I press the start push button, then current will come here to this point, and then through this coil, current will be returning to the, so the circuit will be closed. Okay, good. We have understood this much. Now what I need to do, I have to give this holding. I have to make this holding. So you connect one start push button, start point from this start. Now we have to connect it in parallel. So one is connected like this, and another one will be connected like this. This point and this point are same point, isn't it? So I can simply connect it from here. Like this. Got it? Once again, the connections you can see here. This is what I was expecting, and I am not completing each and everything. Now, we want to do, we want that we should connect this with our PLC, isn't it? So how to connect with PLC and what modifications? This is an electrical hardware connection, and now if you press this start push button and then release it, then your motor will start and it will continue to run. No doubt on that. What modification is required if we want to start this particular motor from remote area like PLC? Okay. Now we modify this circuit. So the same way, the fuse will be there, the bulb relay will be there. Then what? Then we will connect a remote stop. Then there will be the local stop, same. Now local start and the coil and the holding. Now we want to start it from remote, is that it? So I can give a start contact, remote start parallel to the local start. So this is the P2P for this particular thing. But you can see here that we have, if you start from local or if you start from remote, both are directly connected. So we cannot connect like this. We will be using here one remote local selector switch. We will be using one remote local selector switch instead of connecting like this. Now your part will be, you will be doing the same thing once again. Kindly do it. Give those numbers as well. Do the P2P by your own, and then you modify this panel. Then connect all the panels. You also draw this type of cards or PLC, and then join each and every point directly live from this panel to with this PLC. I will definitely be showing on the next class, but prior to that, I want you all should submit this particular task. Okay, just do the P2P, make the panel, connect all the points with your PLC input and PLC output, and if possible, then write the ladder logic diagram. If possible, if you can, otherwise no need, but at least you make this connection. I hope you can right now. This is
मेरा ड्राइंग में वो देख सकते हैं क्या, उसमें क्या प्रॉब्लम है, उसमें क्या गलती है उसमें? कौशिक
थोड़ा सा देखना पड़ेगा मुझको, क्योंकि थोड़ा काम से टाइप का लग रहा है कनेक्शन में, because exactly I ignored or I didn't see because you didn't submit the P2P, no. So if you submit the P2P along with this wiring diagram, then it becomes easy to check what you have done. Okay. Now from where you started your LCP, MCB, no, MCB से निकला. Okay, I will check it later on and it will tell you if there is any mistake. Now all can do this drawing, P2P drawing, wiring diagram, and your panel wiring. Okay. Okay. Kindly do it once. If you complete it, no, then you will be understanding so many things, and definitely there will be some confusions. There will be arising in your mind. No doubt, I want that. Okay, you should do mistake, or if you do mistake, then only it is possible that you can get corrected. If you do not do it, you will be thinking that okay, I will be able to do it, and I will do it later on, and it is not going to happen anymore. You will not do it way in any way. So better you do it since you are here. Just simple draw the things and give the connections. Then if you want, then you extend your connection with the this what we say, indicators, like your, this will be your run or on off, isn't it? This will be on, this will be off, this will be trip. So you can extend and you can. Now everybody can handle this softwares. Are you comfortable with this software? So this was our Alan Bradley software, isn't it? This is your Alan Bradley software, and this is your sister software. This is your DCS software that I have given you, and this was your PLC software that we already did, isn't it? Now we have seen that there are data files, there were program files, and we already seen that how we can find out the IOs where it has been assigned for both PLC as well as in your DCS. Okay. Now one part left here, it was your timer and counter control. It's not a timer counter that we didn't do in our previous lecture. So today I'm just introducing both your timer, counter, and other symbols. Okay, for your ladder, because I hope the basic ladder you know right now. Okay, so when we talk about our timer, so this is our timer. So we are having three types of timers. One is your on delay timer, off delay timer, or retentive timer. Okay. So what is your on delay timer? On delay timer
On the timer sir on टाइम में थोड़ा डिले रखिएगा.
means when a signal is received, then the timer starts. Okay. So you can see here there are in case of your LN20 PLC, it is assigned, timer is assigned as your T4:0, T4:1, etc. Isn't it? So data file 4, fourth data file is specifically for your timer in case of your LN20 PLC. Now, when we talk this timer, then there are some bits. Likewise, your one signal is for your enable, and this is your en bit or enable bit. This is your done bit, and one is your tt bit. What is tt bit? Tt bits means your timer timing. Okay, so you can see here timer has three output bits. Likewise, your en, dn, and tt bit. So en means enable. Whenever you give a the signals from the left of this timer, all the signals are true, all the logic is true, so current is coming or current is going to this timer, then it is on, enable bit is on. Okay, and your tt bit starts counting. So when the I:0/0 is 1, if this is 1 means what? This run is true. The en bit becomes 1. En bit becomes 1, and timer your T4:0 is on. Timer is on immediately. So when input I:0/0 is 1 means all the logic to the left is true, then the timer is on and T4:0 is 1. Next, at the same time, TT bit becomes 1, means EN bit 1 and TT bit is 1, and DN bit remains 0, means this done bit will be 0, EN bit and TT bit will be 1. Timer starts counting, and the value is stored in accumulator. So this is our accumulator. So in this accumulator, all the values will be stored, and timer starts counting. So you have to set this preset and timer base. So there are three ways, like one, you can select base 0.01 or you can select 0.001. So what is the time delay? The time delay depends on the preset and the time base. Okay, so suppose I have selected base 0.1, this will be multiplied with the preset. Suppose I have selected 100, so it will be giving me a 10-second delay. Okay. So there will be only 10-second delay if I select a base, say 0.1 or 0.01. So we are having three ways, 1, 0.01 and 0.001 right now. When the value in the accumulator becomes equal to or greater than the set value in preset, done bit becomes 1 and TT bit becomes 0. So the moment suppose you have set 10-second delay is 10 seconds, and the timer starts now and it is start counting, and when the 10 seconds will be elapsed, the done bit will become 1. This done bit will become 1 and your TT bit becomes 0. Okay, enable bit remains 1. So TT bit becomes 0, done becomes 1, and your enable bit remains 1. Now, how much this timer, this enable and done will be 1? Until and unless this input or this logic to the left side goes 0, this will remain 1. Okay, this will continue as 1 until and unless this goes 0. So we try to understand this with this particular logic and the timer function. So what I have written here, that there is a input switch I0 and there is a timer T4:0. Timer base is given as 1, that means it will count 1 second, and then preset is set as 20. So the total delay will be your 20 second, and see how it will work. So when timer is on, when input 0 becomes 1, means this input 0 becomes 1, then this rung will be 1. Just I change the color of it. So when this is 1, this rung will allow current to pass here and the timer will become on. Timer will be 1. The moment this timer is on, then EN and TT bit becomes 1. So this EN bit is 1. TT bit is not shown here in face of this ladder, but it is there in your data register. So TT bit also becomes 1 and EN bit becomes 1. Then what happens? The output and output 2, output 1 and output 2 becomes 1. Why? Because see, here I have taken 3 outputs. One is connected with your EN bit. How I am writing it? T4:0. This is the T4:0, this timer. How I am addressing it? I am writing it as T4:0 slash your EN. So here the bit is specified. Which bits I want to use. So I am using EN bit here to trigger my O0. Now, the moment this is 1, EN bit becomes 1 and TT bit becomes 1. Thus, O0 output 1 will become 1 or glow, it is on. Simultaneously, the TT bit is also 1. See here, the TT bit is also 1. So since TT bit is 1, we are using a check for 1. So this output will also 1. So output 2 is on. So right now you see, the moment I have pressed this input 1, both the output 1 and 2 on. Now the timer will start counting, isn't it? So after 20 seconds, what will happen? We know EN bit is 1, TT bit is 1 right now, and DN bit is 0. After 10 seconds, the moment 10 seconds is elapsed, this TT bit goes 0 and done bit goes 1. So this is 1, check for 1. So my output 3 will be on and output 2 will be off. You can check it with the simple circuit in our lab, or if you are having some, you can go through this simulator that I have already given to you. Both the PLC and DCS simulator are there. Now see, after 20 seconds, output 3 becomes 1 and output 2 becomes 0. This is off, and done bit becomes 1 and TT bit becomes 0. So this is what your on delay timer, and output 1 and 3 remains 1 till this is 0. Means until and unless this goes 0 once again, this will be on. Output 3 will be on or output 1 will be on. Got it? So I have just make a simple, very simple circuit to make you people understood the regarding this timer, T on delay timer. Okay, got it, everybody? If you want, you can take a snapshot right now. Now you see off delay timer. We have just now understood that on delay timer. Now we try to understand the off delay timer, how off delay timer works. So unlike T on delay timer, EN and DN bit means enable bit and done bit, both on case of your off delay timer goes high as soon as the enable signal is received. Means the moment I'll be pressing this input, this logic is true, both EN and DN will become 1 in case of your off delay timer. Both will be high immediately. And TT bit remains low as you show in case of your off delay timer. So output 1, this output right now, and output 3 becomes on. When the enable signal goes low, if this goes low, EN bit goes low and the T off timer starts timing. After, if it is 1, once it is 1, until and unless it goes low, this timer doesn't start counting. Okay. Once your enable signal is low, then your EN bit goes low. This bit goes low. And your done bit remains 1. Done bit remains 1 and TT bit becomes 1. This goes low. Got the difference? In case of on delay timer, what happens? The moment I am just pressing the signal becomes high or true, then timer enable and TT bit goes 1, done bit remains 0. Once time is elapsed, then done bit becomes high and TT bit goes low. Enable remains 1. But in case of your off delay timer, the enable goes down and when the signal goes down, and then timer starts counting. Okay, so this is the difference between your off delay timer and your on delay timer. Output 1 is thus off and output 2 is on and output 3 remains on, not out. Last one is your retentive timer and your reset instruction. Retentive timer means what? Which can retain the time. The properties of RTO are same as T-on. Means T-on and this on delay timer and the retentive timer has no other difference. But RTO can retain the accumulated values. Even timer goes off, the RTO retain the values. This type of timer can be used to find the total running hours. Means if you want to suppose you want the total running hours of a motor you want to calculate. So the moment the motor starts, you can trigger one RTO and it will be calculating, it will be counting all the times, and then the motor goes off, your RTO goes off, but the value will be stored in the RTO. To reset this particular type of your timer, we have to use one special instruction called RES. So if this is triggered, then only this will reset, otherwise it will go on counting. Okay, so this is called your retentive type timer, retentive timer. Okay. Now this is for regarding what? This is regarding our PLC timers. Okay. And if we see the timer for our DCS, add blocks, timer, if I want a timer. I can use any kind of, there are so many things. It's on the timer. So in our DCS, we can simply use a on delay timer block, and I can see there is a CLR bar, means your enable bar. The moment this signal will come, the timer will become on, and then I can set the timings, and there are the pins given already, like millisecond, second, minutes, hours, and days. So whatever you want, you select the whatever timings you want on this timer. Okay, so you can select your millisecond, second, minutes, hours, and to assign this time, you have to, what you have to do, you have to first generate one um, what we say, the constants. So we have to generate some constants here first, and suppose you want 700 seconds or 900 seconds or 1000 seconds, 10,000 seconds or so. So you have to generate first the constant here, and you have to add it simply here. So suppose I want 3-second delay, so I can assign here, suppose seconds. I am double clicking here, going to the temporary text, and there are 3, so I can simply click on this and it will start working. Okay, just I have to connect the enable bar with something. Okay, anybody has any questions regarding this timer? Anybody has any doubts? Okay, so next part is our counter. Next one is a counter. Where is the counter? So counter, as the name indicates, it's count. You know that it will be used for your counting purpose. And there are 2 types of counters, like CTU and CTD, counter up and counter down. Okay. So in case of our counter, it is your C5 data file in for your Allen Bradley PLCs. Okay. The fifth file is reserved for your counter. 4 data file 4 is for timer, data file 5 is for your counter. So how we assign as your C5:0, and this C5:0 exactly means that the accumulator address. Okay, so here is a simple logic I have written for your better understanding, that this is a CTU, isn't it? And CTU means counter up, and this is a CTD means counter down. So what are the different bits we get in our timer? One is your CU, counter up, C counter down, done bit, your OV, and UN. So CU is count up enable, means this is 1 if this 1 if the enable signal to CTU is high. So the moment this is 1, this particular left side signal, the moment this is 1, this CU bit becomes 1. Okay. CD is equal to if the enable signal to CTD is high. If this bit is high, then your CD will be 1. Done. If accumulated value is greater than or equal to your preset, so you can see here there are preset, and you can select the preset first, or you can say you can use the accumulator value to this. Now suppose where I can use this particular type of counter also. So suppose I want a to make it logic for car park, say for car park, and suppose there are two gates. One is here, one is here. This is your entry, and this is say your exit. What I am doing, I can put a sensor here, put a sensor here, and I know that okay, there are suppose 10 slots. I can park 10 cars here. Okay. So by any means there are 10. Now the moment I have connected this particular sensor, I have connected here in my channel number 1, and this is what entry input 1 I:0/0 means this sensor I have connected with to the channel number 1 of my PLC, isn't it? Now if a car comes here, this sensor will sense and it will give a signal to this counter. This counter will go up high, and your accumulated data will be stored in the accumulator. Okay, so it will be 1. Suppose car number 2 is coming, the accumulator will go to. Third car is coming, it will be 3, and then one car goes out. When the car is going out, the exit signal, this is receiving. So this is my input number 2. So this is my input number 2. The moment it is high, CTD is high. So if this is high, then what it will do? It will minus the counter accumulated value. So once again counter will become 2. So this way, the moment car comes in, this sensor sense, this gives a signal to here, and from here the signal goes to my counter. Counter counts, or it makes +1 and store the value in the accumulator, and the same accumulator I am using here for both up and down. You can see here. So let me double it. You can see here I am using C5:0, and here also I am using C5:0. That means the same accumulator address I am using for counter up and counter down. So if car is entering, C5:0 is storing 1. Another car C5:0 is 2. Another car C5:0 accumulator is 3. And one car goes out, then C5:0 accumulator is decreasing by 1. So this is the way how we can assign or use the counter, both counter up and counter down. Clear?
Yes, sir.
So this was left actually. This was the two basic symbols that was left. And what else you have to know? There are something like your integer files, float files, and the control status. These are a few files have been left. And regarding your DCS files, I hope you are trying at your home to understand this. If there is any questions, you can ask me. And if you are not opening this, then you will definitely be having no questions. I know. So no questions. Good. No questions. दो चीज को समझाता है. Either you have understood everything, which is not possible at all. I know it very well. It simply means that you are not playing with these softwares, not going through these logics. Once you go through these logics, there will be immense of questions. I know it. I'll be overburdened by your questions. Why this is this? Why this is that? There will be lots of questions. So, anyways, try practicing, because I know you all are busy with your works also. Try practicing whatever I have covered today, the P2P drawing, and this project, at least I assure you, I will be taking from you this assignment. You all have to submit this. Make a P2P drawing, make the structure, make the panel, insert all the components, connect all the wires, and submit it. Okay.
We can submit, sir, by writing the page, or we have to draw something in software.
No
This
need to go for any software. So you simply take a pen and paper. Means सीखने के लिए थोड़ा ही ना software चाहिए.
Pen and paper से हम लोग just wiring.
Yeah, definitely. My intention is simple. My intention is that you should be clear your doubt by any means. If you can go with the software, it is okay. No need to go for any software also. You simply take a page, take a big drawing sheet or drawing book, and draw it nicely so that you also can understand and I can understand it. Got it? So
Okay, sir.
you can take 2 or 3 color pen, so that you cannot jumbled up with the wires when you are connecting in the actual wiring, because it will be jumbled. No, when you will be trying to do the actual wiring, it will become really jumbled. Okay, so for today it's okay.
When will you upload this video, sir?
Today's video.
Yeah, today.
Yeah, today's video will be uploaded by not by today, because it will be uploaded by tomorrow. Okay.
Okay, sir. Please tomorrow.
Yeah.
Oh,
Okay.
okay.
Okay. Bye bye. Bye bye everybody. And Sudeep ji, next class will be on your topic. You have waited a lot for this, so don't miss next class. Chaliye, bye bye.
Okay, sir. Bye. Day after tomorrow, sir. Class.
Yeah, day after.